Welcome to today's webinar. The topic today is most frequently asked questions answered by Luba's support team. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Luba Software, for instance, German and English webinars, technical content of the website, customer projects, and so on. I will be the moderator today, and I present the first 3 questions. And I answered the questions with the help of our software. And the second part will be done or will be presented by my colleague Stefan Hoffmann. He is the head of customer support. He prepared the 6 questions. 3 will be answered by me and 3 by him. And when one of us presents, the other answers the questions. You can ask questions with that panel. I switch off my webcam that you can see the full screen. Just press the button with the question mark, then enter your question in that field, press send, and we will receive your question and we will answer you. The other way is to watch the entire webinar and then email your questions to info@global.com. Okay, then let's start with the first question. The first question is, how do I organize my projects? I can organize my projects in the Global Center. The people who already work with RFEM 6 know that. I would like to give you some tips and an overview how you can work with the Global Center and news what we are implemented in the Global Center. Let's start with the models. The most important tool in the Global Center to organize your projects. Let's create a new project with a right click to projects. I can create new project. Let's call it example project. Okay, that's the new project. And I would like to create a sub-project. Again, right-click to example project, then create new project, and the new project should be model house 1. I can add description here if I want. So then, again, a right-click to model house, and I create a new file, RFEM model in that case, and I call it house variant 1. Okay. Turn back to the Global Center. Then you can see the file here. And if you switch to the list, you can add different columns here. For example, created in version, created by user, or I can remove them with a double click and can add use add-ons or modified by company or created by company as you want. Different types are available. Now you can see the added columns here. Okay, then I can open, for example, for the example project with a right click the folder location and the Windows Explorer was opened. And I can create a new folder also here. So with a right click, new folder, and I call it model house 2. Okay, I decrease it a little bit that we can see both. So, okay. And now I can do a right click to this example project and can select connect folder as project. And I select this Windows folder, select it. Okay. And now where are 2 sub-projects? Now that's another possibility to create a project. So then I can also do a right click to model house 2, for example, and then select disconnect. Then the project was deleted here, but not in the Windows Explorer. It's also a small tip for you. It remains here. So then other features delete, that's clear. Then set as current, then it is the current project. If you start in RFEM or RSTAB to create a new file, then the program suggests this project to save it there. So, and you can also go back to the project properties here and add a description, for example. Okay, that's all to the models. Let's turn to the extranet and my account. So you can see the extranet messages here, or what's quite important, the development. You can see implemented features in a certain add-on, for example, or you can select all, then you can see all implemented features. You can see open features for certain products or all products. Then you can submit a feature request, and maybe it will be implemented in the future. Then, for example, you can see the GeoZone tool requests. Those are my requests in the past. Then the API and cloud. Those are calculations from my side from the past. Then you can see here the data of you and of the company, your licenses, and so on. Then we turn to the models and templates. The model templates category in the Toolbar Center provides an overview of the models you have saved as template files. In my case, it's empty. And an important message: the save as template function in the file menu in RFEM allows you to save your current model as a template. Then you can see the blocks. Those are parameterized, and most of the models where are parameters implemented. Let's go to this view, the tiles. Simple models and more complex models, for example, curved surfaces and so on, concrete structures. A lot of blocks are available. Just use them. That's quite easy to handle. Then the joint templates. You can select certain the templates of joints. You can use it in the add-on, also in the steel joints add-on. for example, also number of members or joints with ribs, cleat, and so on. Then that's a quite new part of the Global Center, the component series. We are in the development of the new add-on components. It's currently in alpha version, means it's in preparation, and in the future you can use the values of such joints and compare them with, you can compare your internal forces with the maximum forces of the joint. And API scripts, there are already sample scripts that you also can use for your project. Okay, that should be all for this question. Let's turn back to RFEM. The next question is, can I design longitudinal filled welds according to Eurocode 3, part 8 in RFEM 6? Yes, that's possible now. Soon we will release that feature, and I can show you how to do that. I've prepared a simple single span beam here made of a cross section HE 180A. Imagine you need to use a girder with a maximum height of 175 millimeters. It's not possible, as you can see on the design ratio, with the HE 180A, and it's also not possible with an HE 180B. That's why we create a welded cross section. At first, it's clear. I go back to the base data. It's necessary to activate the steel design for that feature. Then, we create the welded section. I edit this used section. I turn to the library above and I select Finward I section. So, and before I enter the geometry, I go back to the main part here, main section, and I select here welded. Okay, then I enter the parameters. Maximum height should be 175 millimeters. Then the other values can remain, but not the thickness of the flange. Should be 15 millimeters, and the weld should be 3 millimeters. Okay. Then I have to activate the weld design. I turn to the navigator data, then steel design and the ultimate configurations. Default. I can turn to that chapter here also when I use a double click on the beam. Then the design properties are activated and I can find the design configuration here, and I can edit it also with that button. So, and then I have to activate the design of the longitudinal filled welds. The correlation factor should be determined according to the Eurocode. It's dependent from the material, and in our case it should be 0.8 because we have a material S235. And if you want, you can also use a user-defined correlation factor. In most cases, we will use the automatic data determination according to Eurocode. Okay, so then I start the steel design again. So the combinations are calculated in parallel. So let's turn to the design ratios on members. Yeah, and you can see there's an error. If I double click on the line, the details are opened and you can see the throat thickness of one or more longitudinal fillet welds is smaller than the limit according to Eurocode 3. Now the program checks that automatically. In that case, the weld is too small, and we need to increase the weld. So I turn back to the navigator data and I do a double click on the cross section and I increase the weld to 4 millimeters. Okay. Then I run the steel design again. So, and now, the design of the weld is done. Double click on it and I can see the design checks. The 0.8 can we find here, the correlation factor, then the thickness of the weld, and the design check ratio is approximately by 40%. And of course, you can also print the formulas and so on the printer or in the printout report. Okay, that should be all to this question and to this model. The next question is, how can I smooth results in RFEM 6? That's an often asked question. You can do that with a surface results adjustment. In RFEM 5, we called it average region. And such a surface results adjustment describes an area in the model whose graphical results are not represented by the actual diagrams, but as mean values. And you can use a user-defined adjustment area to evaluate the smoothed surface internal forces. You can see that ceiling panel here and a wall here. Imagine it has thickness of 20 centimeters. And you can see there are singularities at the end of the wall here. So, and we would like to use such a surface results adjustment to smooth the results. So to compare the results, I copy that ceiling panel, select all, then I use the move and copy function, create a copy, 6 meters in Y direction, and including loading. Okay. So then I turn to the navigator data, and under special objects, you can find the surface results adjustment. And you can find them also here in the menu, insert, special objects, surface results adjustments, and I open the dialog box. At first, I have to assign a surface. That surface, okay. Then, you can select different shapes here, rectangle, circle, ellipse, and polygon. I use rectangle. The dimensions in our case should be 20 by 20 centimeters. And I select the node. So, and to define the position correctly, I move it to 10 centimeters to depict the wall end correctly. So, and then there are different adjustment types. The default setting is for the direction U, averaging of my, mxy, and so on. And it's for basic internal forces in surface direction y. So, and the second line here is the default setting for basic internal forces in surface direction x. So then you have also different other options, for example, the contact stress area. This option is currently only relevant for the steel joints add-on. Then user defined, if I select it, I can edit it. So, and the results of selected types of internal forces are averaged. You can use only mx or mx and my, or all as you want. So then 0, the results within the area are set to 0. You can select the internal forces here, and all are set to 0. And the last is none, and the surface internal forces are not averaged, but displayed in the regular way. For example, if you want to adjust only the internal forces in one direction, or to smooth that results. So I use the default setting, press OK. So, and then we calculate all again. And let's compare the internal forces for both slabs. The maximum value for both is 90.5 or minus 90.5. The mx internal forces in that case. And if I want to see what the maximum value is here, I can, for example, deselect that slab here, hide selected objects. Okay, and now the maximum value is minus 16. That's the possibility to smooth results in RFEM 6. Okay, those are the first 3 questions. The next questions are asked and answered by Stefan. Stefan, it's your turn.
Thank you, Andreas. I will continue with the next topic. The next question is, where can I find specific RWIND settings in RFEM 6.12 and later? As you have maybe already realized, we changed the GUI in RFEM 6 a bit to be able to hand over more data to RWIND with the GUI in RFEM 6 without stepping directly into RWIND. Let's start with the basics. So usually at first you activate the add-on wind simulation, and you can choose the standard group for your wind profile in order to determine your automatic wind profile for your region. If you're already interested in adding up a terrain to represent your location specific behavior of the wind, maybe by trees or some mountains, you can already activate a terrain in the base data terrain settings, and you can choose between no terrain, of course, a horizontal plane, an inclined plane, some table values, or as I am using, and this is most likely also the first change, an IFC file model objects. So this is no more found in the mesh settings to adjust the IFC as a terrain. You already input it as the base data in the tab of terrain. So I'm simply using an IFC file where I've modeled a simple shape of my terrain, and you can do some more inputs on the size of your terrain in already here. So if we jump into the model, you are of course known that in the mesh settings, you have a tab of wind simulation, and for the regular customers, you already realize that this tab has changed a lot from the GUI. So we moved some parts, of course, and you now have the option to assign objects from shrink wrapping. So the shrink wrapping mesh, which is later necessary for the calculation in our wind, in order to be assigned to your main structure or surrounding objects. So you can already split in over here, but later on also in the objects. This is currently not in use. You can as well choose to activate the terrain, which we set in the base data to be considered for the calculation. You can also jump into the base data. You can moreover, as already known, adjust the level of details for your members. You can choose to close hollow sections. You can consider a surface thickness in general already, and the two known options to keep our wind results if the mesh is deleted, and or to run our wind in the silent mode. As known, you also have settings in the load cases from the analysis type wind simulation. So if we jump into the tab, this has not changed, I think, a lot. You can assign wind simulation analysis settings, where you can, for example, differ between steady flow and transient flow. You can hit some more options to be handed over to our wind. You can also step into the tabs to add some more input for the wind tunnel. The wind profile did not change from my point of view, so you can simply assign a wind profile according to a standard and hand this over to our wind directly. Some more checkboxes at the bottom. Everything is usually explained more detailed in our online manual. The biggest change, in contrast to the mesh settings, is now that every object, if you click X, for example, in one surface, has a specific wind simulation setting, which you can activate. And if you see this tab, you can see that you can now assign different shrink wrapping settings for surfaces. So if you have maybe a small surface, you can assign a even finer mesh later on, because you are interested maybe in facade engineering and some results on this point. And if you have a bigger surface, which is not most of interest, you can assign a coarser mesh. You can also define the roughness and permeability as an object. So as you are maybe used already in our wind, you can use like a closed surface and enter some permeable options for it, so that the mesh will not be fine, but it will be considered as permeability later on. You can also check on to consider surface thickness above, and an also interesting option is that you can simply also exclude this object from the wind tunnel. I think what we did not change is that you have, of course, your wind simulation analysis results, and you can still split to show it on the original model and or the computational model. We will step to the next question. The next question is, can I control the shear coupling for laminated glass in RFEM 6? So usually, of course, having laminated glass, the shear coupling is quite of interest, because if you have a layered plane where you have two panels of glass and one foil in the middle, then one worst case is that you do not take the shear coupling into account, having big deformations, having stresses only in the glass planes, but it might also be of interest. That is why we use laminated glass, that you can take into consideration the shear coupling. Sometimes you are allowed to do this. And just with regards to the German standard 1808-1, it offers two requirements in the chapter 7.2.1. It mentions when determining the stress and deformation of laminated glass and laminated safety glass, favorable shear coupling between the individual panes must not be assumed. But in the next chapter, 7.2.2, in the case of an unfavorable shear coupling, e.g. in the case of restrained stresses, full shear coupling must be assumed. So you usually have to consider both states doing your calculations. Sometimes, of course, because it's not every time common sense that you can see the effect of the shear coupling just from your engineer's point of view, but it's quite easy, and we will show it in this model. So first, a quick look at our model. It's a glass pane with 4 point supports, and I have created a thickness from the type glass composition. I have 3 layers, 2 times float glass, 8 millimeters, and 1 foil in the middle. You can use the foil, of course, with material values from our material library. I'm using a foil with a load under 3 minutes, so the E modulus will already change for our foil layer. And this is my glass composition. For the calculation, you have to assign, or this usually automatically assign the first one, a glass composition model, where you can later on also choose from a solid model, where you can then take into account also isolated glassing. But currently you can differ between coupled and uncoupled shear coupling between the glass layers. So I have defined uncoupled, so there is no shear coupling in my main model. So how to use or how to consider both shear couplings? It's quite easy in RFEM 6. So we do this checking our design situations. And once you check glass design, you can see a further added option at the bottom in the design situations. It mentions inverse shear coupling between layers for surfaces with glass compositions. So let's remember, we have a glass composition model without shear coupling. So for every load combination in the design situation 1, if we do not check this checkbox, this is uncoupled. And we can simply copy this design situation and check this checkbox for the same load combinations, where we will then take into consideration the full shear coupling. Just by simple adding up an option, load combinations will be calculated automatically. So once we step quickly into our design situation 1, no shear coupling, we have a maximum deformation of 50 millimeters approximately. And if we step into the one with full shear coupling, the deformation, of course, reduces as expected, related to the theory behind for our 2D sub-stiffness. And I think the most interesting part is, of course, then later on the glass design. I have done 2 sections through the model, and we are, of course, above our design ratio, so we would have to adjust our model, but mainly not taking into consideration the shear coupling, we would expect on point supports to have the biggest ratio in the middle of the field, but this would decrease once we can take into consideration the shear coupling. But this affects usually, most likely, our support points with the point supports, that the stress ratio may increase. So it's not only usually in the case of restrained stresses, but from my understanding and from my experience, usually you can also expect that the stresses may increase with a full shear coupling at the place of point supports. You can take this into consideration by simply activating this option in the design situation. Let's step to the last question for today. We will stay in the model. And the last question is, my mouse is not working as usually. What can I do? Let's reflect the mouse function. So with the left mouse, you can select items. With the mouse wheel, pressing it down, you can pan. With the right mouse, you usually get a context menu with some options. If you hit Control on the keyboard and press the middle mouse button, then you can rotate. If you select a node or object before and hit the Alt key and press the middle mouse button, you can rotate around that object. And well, you can move, of course, with the middle mouse. And what happens if you only have a mouse with one key, or if you are sitting at your laptop where you do not have a middle mouse button? We introduced this option over here to move, zoom, rotate. And if you activate this, the mouse action will change. So with the left mouse clicking, you can move. With holding Shift, you can zoom by moving the mouse and clicking the left mouse button. And of course, with Control or Alt, you can rotate by just simply clicking the left mouse button. So if you maybe cannot use, or you think you would like to select something and it's not working, then just simply remember that this option might be active, and it also affects the view cube, so it's not fully functioning anymore. So simply, if you are a bit confused, remember this option, uncheck it, and then you have your normal mouse options back again. What I would like to add up is the function over here to add something to the selection or create a new selection. So usually you can, of course, mark the surface, hit Control key, and add up some more objects into the selection. But if you are tired and you do not want to do this, you can check this box, this button, and click items, objects once after each other. But this may face some trouble if you do not remember you activated it, because then a left click will not undo the selection. You have to click Escape. The last two buttons, what I would like to add to this topic, are these two. So both allow to interact with the model and the table. So as we had in the glass design, if you have results and you click in one row, you will see a red arrow pointing at the place. So if this is not the case, or if you click on one node and it is not used in the, or it is not highlighted in the table, then you can simply remember both buttons, and they should be the reason why it is not highlighted, vice versa. All right, so that's enough from me. Thank you for your attention, and I will now hand back to Andreas. Thanks.
Thank you, Stefan, for your presentation. I have an additional hint to our online courses. The RFEM 6 course, it's a course for beginners. The Eurocode 2 course for the concrete design with RFEM 6. Eurocode 3 course for the steel design. The Eurocode 5 course for the timber design. And the Eurocode 8 course for the earthquake design. For more information, just scan the QR codes or press the buttons here. Then I would introduce you the free online services. For example, the Global community. A lot of users join the Global community. You can ask questions there, and our team or other users will answer you. It's a very good tool, I think. Then the geozone tool. It's for the determination of snow, wind, and earthquake loads. Then the cross-section properties. You can download 3D models from our website to use it as template, for example. If you don't already use our software, just download the free 90-day trial version. The programs RFEM and RSTAP contains all the add-ons. You can also download our section or our RWIND. If you click on the link or scan the QR code, you can see all our free online services. You can find more information on our website, global.com. For example, the events, the knowledge base articles. You can ask Mia, our AI assistant, every day and every night, 24/7, and she will answer you. Okay, that should be also all from my side. I thank you for your attention. Thanks to Stefan for his part of the presentation and for the preparation. I wish you all a nice rest of the day. Bye-bye.